Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics that every civil engineer witness whenever they are working at the site. That is shrinkage cracks. In every concrete and every engineer, it is a common phenomenon in the site that shrinkage crack is appears. Today's video, I will discuss what is shrinkage cracks, what the different types of shrinkage cracks and why the shrinkage cracks is generating and what is the remedial measure to avoid this. So stay tuned until then to get the full information about the shrinkage and the shrinkage cracks of the concrete. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. तो आज का टॉपिक है श्रिंकेज क्रैक्स इन कंक्रीट. श्रिंकेज कंक्रीट क्रैक्स क्या होता है दैट आई विल डिस्कस ईच एंड एवरी स्टेज. And it is a common phenomenon in every concrete we are witnessing this shrinkage cracks. To understand the shrinkage cracks, first we need to know what is shrinkage, because shrinkage is developing. That is why the shrinkage cracks is appear. So first we need to know what is shrinkage. Shrinkage of concrete refers to the reduction in volume of concrete as it loses moisture or undergoes chemical reaction over time. So what is shrinkage of concrete? That is reduction in volume. And why the volume is reduction? Because if जो मॉइस्चर होता है मॉइस्चर लॉस होता है, नहीं तो इसका जो केमिकल रिएक्शन होता है दैट इज वी कॉल्ड द हार्डेशन और द हाइड्रेशन ऑफ द सीमेंट एंड वाटर. With this chemical reaction also the volume is reduction. So whenever this volume reduction is occur inside the concrete, we call it shrinkage. This volume reduction occurs due to water evaporation, chemical hydration, or internal volume change can lead to cracking if the concrete is resistant or unable to accommodate this shrinkage freely. So क्या होता है inside the concrete और जब ये shrink होता है then there is a tensile stress generating. If the tensile stress is greater than the tensile stress capacity of the concrete, then this shrinkage cracks will appear. Then I will come later. But the shrinkage is that this is the volume reduction. Maybe it may be due to the evaporation loss, due to the chemical change, due to the chemical reaction, then the volume is reduction. So whatever the reason, if the concrete volume is changes or reduction is there, that is called the shrinkage. So this is clear. Shrinkage यही है कि वॉल्यूम चेंज होता है, वॉल्यूम कम हो जाता है केमिकल रिएक्शन की वजह से एंड अंडरगो इवापोरेशन और मॉइस्चर लॉस होने की वजह से और इंटरनल वॉल्यूम चेंज होता है. सो इस इज कॉल्ड द श्रिंकेज. तो नेक्स्ट हमको जानने का है व्हाट इज श्रिंकेज क्रैक्स. नाउ हम जान गए श्रिंकेज क्या है. श्रिंकेज इज नथिंग बट द रिडक्शन इन वॉल्यूम ऑफ कंक्रीट. नाउ श्रिंकेज क्रैक्स क्या है? व्हाट इज श्रिंकेज क्रैक्स? श्रिंकेज क्रैक्स इन कंक्रीट ऑकर ड्यू टू द रिडक्शन इन वॉल्यूम of the concrete as it loses over time. As the concrete dries and water evaporates, it experiences a reduction in volume which leads to tensile stress. Already हम जो बात किया था टेंसाइल स्ट्रेस होता है. ये टेंसाइल स्ट्रेस जब भी टेंसाइल स्ट्रेस कैरिंग कैपेसिटी से कम हो ज्यादा हो जाता है तो क्रैक होता है. If this tensile stress exceed the tensile strength of the concrete, it result in shrinkage cracks. So क्या होता है जब भी हम लोग कंक्रीट करते हैं, कंक्रीट सेट होता है, so it is a phenomenon that the higher particles will settle down and the appear light particles will come out. तो क्या होता है ना, एग्रीगेट जो होता है धीरे धीरे सेट होना चालू होता है एंड वाटर कमिंग आउट द सरफेस. That's called the bleeding. So we will all witness after concrete there is a thin layer of water is coming. That is called the bleeding. Now, this bleeding has the important role in the shrinkage cracks. Why? The cracks only appears if evaporation rate is faster than the bleeding rate. That means concrete जब भी हमने किया तो bleeding चालू हुआ, थोड़ा देर होता ही है, और ये water जो evaporation that is also starting. So if the evaporation rate is higher than the bleeding rate, the cracks will generate. If the evaporation rate is less, then the cracks will not generate. This is the very important things. Shrinkage cracks क्यों generate होता है? Why shrinkage cracks is generating? That is the phenomenon that it is changing the reduction in the volume and evaporation of the water, and if it is faster than the bleeding rate, then the cracks will generate. It is a common phenomenon. So these are the shrinkage cracks. Now हमको जानने का है how this shrinkage cracks is developing. What is the process? There is a different process. So first phenomenon, what we are doing, we are placing the concrete. Now we have a mixed design, we have a proportion of concrete. Okay, अंदर क्या होगा, coarse aggregate, fine aggregate, water, cement, सब कुछ है. तो उसी वजह से हम लोग concrete place करते हैं, concrete prepare करते हैं, concrete place करते हैं, and then concrete को compact करते हैं. So our work is not done. Now what is happening, then the process start called initial settling and bleeding. As the concrete set, water rises to the surface. It is a common phenomenon because water is lighter particles and the aggregate जो है coarse aggregate fine is the heavier particles. So the due to the gravity, it is a common phenomena. There is a bleeding, the water will come out in the top. It's not that the full bleeding, but it's the very slow process. This happens within the first few hours after placement. तो क्या होता है, अब इनिशियल सेटिंग ऑफ ब्लीडिंग चालू होता है, बट इट्स नॉट द ब्लीडिंग व्हाट वी आर थिंकिंग दैट इफ द ब्लीडिंग इज देयर कंक्रीट रिजेक्ट हो जाता है, बट इट्स अ कॉमन फेनोमेनन, बट इट्स रेट इज वेरी लो. देन वाटर लॉस थ्रू इवापोरेशन, दैट इज प्लास्टिक श्रिंकेज. If the surface water evaporates too quickly due to the wind, heat, or low humidity, it can cause the surface to shrink, leading to the plastic shrinkage cracks. तो हमने अभी ऑलरेडी बताया कि ब्लीडिंग भी होता है, वाटर लॉस भी होता है इवापोरेशन के वजह से. ये इवापोरेशन का रेट अगर ज्यादा हो गया ब्लीडिंग से, तो क्रैक जनरेट होता है. देन हार्डनिंग ऑफ कंक्रीट, तभी क्या होता है, इनिशियल सेटिंग के टाइम के बाद कंक्रीट सेट होना चालू होता है, दैट इज हार्डनिंग ऑफ कंक्रीट. द हाइड्रेशन प्रोसेस बिगिंस एज सीमेंट रिएक्ट्स विद वाटर, हार्डनिंग द कंक्रीट. तो होता है ना, सीमेंट और all we know the cement and water start reacting each other, and we call it the hardation of the cement, and this hardation process gives us the homogeneous and the hardened paste that we call the concrete. So it will start. Then water evaporation from hardened concrete. Not only the plastic concrete, it the from the hardened concrete also, water moisture can lose or evaporate. Over time, water continues to evaporate from the hardened concrete. As the water कंटेंट reduces, the concrete shrinks. तो क्या होता है ना, ये वाटर कंटिन्यूशन इवापोरेट होता रहता है. अभी जब भी इवापोरेट होता है, again this hardening process, that also over the time, not only the within 3 to 4 hours, the concrete is hardening, and the set time also the shrinkage crack is can happen. That's called the drying shrinkage. It's when these stresses exceed the tensile strength of the concrete, that cracks appear. That is the main thing, that the tensile, or the volume change, the tensile stress is created, and if this tensile stress is greater than the tensile strength of the concrete, the cracks will appear. Then initial hydration is the autogenous and the chemical shrinkage. So as hydrogen progress, water is consumed in the cementitious reaction. This leads to autogenous shrinkage due to the internal reduction in volume, even without external drying. तो बाहर से इसको पता नहीं चलता है, पर चालू हो जाता है internally. That called the autogenous and the chemical shrinkage. Then appearance of shrinkage cracks कैसे होता है? Cracks begin to form on the surface and within the body of the concrete when the tensile stress due to the shrinkage exceeds the tensile strength of the concrete. So एक क्या होता है, ये body में surface में आ जाता है, but it's not the structural crack. That is why it is not that much of harmful, but we need to take care very much carefully to avoid the shrinkage cracks. Then propagation of cracks, these cracks can widen over the time, and if the concrete continues to lose moisture, leading to further weakening and potential durability issues. So what we understand, that shrinkage is the reduction in volume. How this shrinkage can happen? Due to the loss of moisture from the concrete itself, or whenever this reaction or the hydration of concrete is happening, that also for the chemical reaction that can be changes. So that is why there is the different shrinkage is there. And when the plastic, in this plastic stage, when the evaporation rate is higher than the bleeding rate, then only the shrinkage cracks will appear. And why the shrinkage cracks is appearing? Because whenever the volume is reduction, then the tensile stress is generated inside the concrete, and if this tensile stress is higher than the tensile strength capacity of the concrete, the cracks will appearing. So these are the thing about the shrinkage cracks and step by step process. Now we'll know what are the different types of shrinkage. It's we only know that it's about the plastic shrinkage. Whenever we do the concrete होने के बाद 3-4 घंटे में हल्का हल्का सा क्रैक आ जाता है randomly, we call this plastic shrinkage. But देर आर डिफरेंट टाइप्स ऑफ श्रिंकेज ऑल्सो. तो हम अभी डिस्कस करेंगे एक एक करके क्या है. तो फर्स्ट थिंग्स इज द प्लास्टिक श्रिंकेज. प्लास्टिक श्रिंकेज ऑकर्स व्हेन कंक्रीट इज इन इट्स प्लास्टिक स्टेट. सो प्लास्टिक स्टेट क्या होता है? जो प्लास्टिक स्टेट यही होता है कि दिस इज पोरेबल, सो इट कैन बी poured inside the mold or inside the shuttering. This stage is called the plastic stage. After the plastic stage, that is it started the initial setting time, हम लोग उसको पोर करते नहीं कर सकते. So that is why it is important to know the initial setting or the plastic state time. So within that time we need to pour the concrete, whatever the vibration and everything we have to clear. So it occurs inside the plastic state typically within the first few hours after placement, and water evaporates faster from the surface than it can be replaced with from within the mix. तो यही होता है कि इवापोरेट होना चालू कर दे. क्यों इवापोरेट होता है? बिकॉज देयर इज अ मॉइस्चर ग्रेडियंट इज क्रिएटेड इनसाइड द कंक्रीट एंड आउटसाइड द एनवायरनमेंट. सो इफ देयर इज द मॉइस्चर ग्रेडियंट, सो ऑलवेज इट विल फ्लो फ्रॉम द हायर स्टेट टू लोअर स्टेट. सो व्हाट इज द हायर स्टेट? दैट इज द इनसाइड द कंक्रीट. एंड फ्रॉम दैट कंक्रीट क्या होगा ना, मॉइस्चर आउटसाइड जाने के ट्राई करेंगे. सो देयर विल बी अ कैपिलरी रिएक्शन विल जनरेट, एंड व्हेन द कैपिलरी रिएक्शन इज जनरेटिंग, with this generate again the volume shrinkage and the tensile stress is generating. So that is why the moisture gradient to create, that is why the plastic shrinkage is created. That is why you are saying that do the proper curing so that the moisture gradient cannot create, or the evaporation can happens only from the water layer we have put above the concrete. वो जो curing करते हैं उससे evaporate होंगे, inside से evaporate नहीं होंगे. That is why curing is very much important. From the surface that it can be within. This causes the concrete surface to shrink, leading to the shallow cracks. Generally happens within 3 to 4 hours. So concrete place करने के बाद ही हमारा जो ये होता है, that is called the plastic shrinkage. So first is created in the plastic shrinkage. Then what is created, that is the thermal shrinkage. What is thermal shrinkage? Thermal shrinkage occurs due to temperature changes in the concrete. As concrete cools after being placed, it shrinks because concrete expands when it heats and contracts when it cools. So rapid cooling, especially in large pours, can lead to cracking. Generally happens within over a week. So it's always a temperature is creating inside the pore, and if the pore temperature and the surface temperature is different or rapid cooling is there, so here is a temperature gradient is created. And if the temperature is gradient created, again the heat loss theory will be there. From the higher temperature, the lower temperature heat will transfer. So again there will be shrink, and there will be a thermal shrinkage crack. Then it is coming chemical and autogenous shrinkage. It is more or likely the same, or it is occur within the same time. So what is chemical shrinkage? Chemical shrinkage is the reduction in the absolute volume of the cement paste as a result of the hydration process. So what is happening in the cement? There is a C4A, C3A, C4A, and C3AF. So there are different chemical inside the cement, and whenever we are adding that water inside the cement, उस सीमेंट क्या होता है, सीमेंट का जो पार्टिकल्स होता है, दैट स्टार्ट रिएक्टिंग विद द वाटर. सो अभी ये केमिकल रिएक्शन होता है. केमिकल रिएक्शन की वजह से हमारा क्या होता है, वॉल्यूम चेंज होता है और वॉल्यूम रिडक्शन होता है. सो दैट इज वाई ऑल्सो द वॉल्यूम चेंज बिकॉज ऑफ द केमिकल रिएक्शन, द वॉल्यूम चेंज और द वॉल्यूम श्रिंक, वट एवर द क्रैक्स इज जनरेटिंग, दैट इज केमिकल श्रिंकेज. During hydration, water or cement paste react to form hydrated hydration products which occupy less space than the combined original volumes of water and cement. Generally happens within 1 month of week. So एक महीने के 2 महीने के अंदर ये हो जाता है. एक महीने के अंदर 2 महीना 3 महीना, ये whatever the chemical shrinkage that is created inside the concrete. Now after chemical, it is coming autogenous. Although this chemical shrinkage and autogenous shrinkage both nearly is equal to same, or it is happening in the same time. This autogenous shrinkage occurs due to the internal moisture loss in the concrete without any evaporation to the external environment. Now, ये बहुत यू नीड टू अंडरस्टैंड वेरी केयरफुली. हमने अभी प्लास्टिक श्रिंकेज के बारे में क्या बताया था कि मॉइस्चर जो इवापोरेट हो रहा है कंक्रीट से बाहर. नाउ ऑटोजेनस मीन्स एक कोई मॉइस्चर बाहर नहीं जा रहा है, बट इनसाइड इट इज हैपनिंग। इनसाइड क्या होता है कि इनसाइड में भी एक पार्ट में मॉइस्चर कम होता है, एक पार्ट में मॉइस्चर ज्यादा होता है, तो मॉइस्चर ग्रेडियंट क्रिएट होता है। तो अगेन मॉइस्चर ग्रेडियंट क्रिएट होगा तो क्या होगा, ज्यादा मॉइस्चर से कम मॉइस्चर में जाएंगे। सो हाइड्रेटेड पार्टिकल से अनहाइड्रेटेड पार्टिकल में मॉइस्चर मूव करेंगे, ड्यू टू दिस मूव again the capillary reaction and the volume reduction is happening, and again the tensile stress created, and that's called the autogenous shrinkage. So environment, it primarily happens in low water cement ratio concrete, usually less than 0.4, where the hydration reaction consume most of the water, leading to internal volume reductions. If inside the concrete, again the moisture gradient created, then moisture move from hydrated particle to unhydrated particle. Due to this capillary movement, cracks generated generally happens within 1 month of time. So this chemical shrinkage and autogenous shrinkage is happening simultaneously, or it is more or less same because of the chemical reaction. This chemical shrinkage and the autogenous shrinkage is created. So what is the remedy for the chemical shrinkage and autogenous shrinkage? So we need to pre-weighted aggregate is there, or we add the fiber to take that tensile stress which is generated due to chemical shrinkage and the autogenous shrinkage. So first become the plastic shrinkage, then thermal shrinkage, then chemical shrinkage, then autogenous, and after that is coming drying shrinkage. Or drying shrinkage occurs when the concrete hardens and loses moisture over time after it has set. Again, it is loses the moisture. इसको भी क्या होता है ना, moisture जब ये हाइड्रेशन प्रोसेस इज अ वेरी स्लो प्रोसेस, और ये 1 महीना 2 महीना अब हम लोग जीजीबीसी को चलता रहता है, तो अभी ये जब ड्राई होता है कंक्रीट, तो उसी टाइम जब ये मॉइस्चर लॉस होता है, दैट कॉल्ड द ड्राइंग मॉइस्चर। तो व्हाट इज द डिफरेंस बिटवीन दिस ड्राइंग मॉइस्चर, ड्राइंग श्रिंकेज एंड द प्लास्टिक श्रिंकेज? प्लास्टिक श्रिंकेज प्लास्टिक स्टेट में होता है, जनरली 3 से 4 घंटे में। सो दैट इज वाई कॉल्ड द प्लास्टिक श्रिंकेज। और ये ड्राइंग श्रिंकेज क्या होता है, ड्यूरिंग द प्रोसेस ऑफ द हार्डनिंग। So this type of shrinkage typically happens as the concrete dries out after its initial curing period. Okay, it is a long term and can lead to permanent volume reductions. It can generate throughout the year. So throughout the years, ये drying shrinkage होता है. So what is the types of shrinkage? Plastic shrinkage, thermal shrinkage, chemical shrinkage, autogenous shrinkage, drying shrinkage. But there are another type of shrinkage, that is carbonation shrinkage. Why? Because of the carbonation, or the carbon dioxide is the villain for that. Carbon dioxide is not good for us, but at the same time it is not good for the concrete also. Concrete भी इसको अच्छा नहीं मानता है। concrete के अंदर अगर कार्बन डाइऑक्साइड चला गया, तो उसका भी दम घुटने लगता है, उसका वॉल्यूम चेंज होता है, उसका केमिकल रिएक्शन होता है। तो क्या होता है, कार्बोनेशन श्रिंकेज ऑकर व्हेन कार्बन डाइऑक्साइड from the atmosphere reacts with the calcium hydroxide, that is the CaOH2 in the hardened concrete to form the calcium carbonate. तो कार्बन डाइऑक्साइड मान लो कि अगर कंक्रीट के अंदर गया, तो इट स्टार्ट रिएक्टिंग विद कैल्शियम हाइड्रोक्साइड and then create the calcium carbonate. And if the calcium carbonate, it is the volume again shrink. This chemical causes the concrete to shrink and can lead the cracks over time. It's a lifelong incident. So carbonation of concrete, it's a lifelong, but it's a very slow process. So how to take that one? You have to टेक केयर द कंक्रीट। में आपको एक लेयर मॉइस्चर ग्रेडियंट बनाना पड़ेगा, या कोई वाटर प्रूफिंग कंक्रीट ये करना पड़ेगा, रेगुलर मेंटेनेंस करना पड़ेगा, ड्यूरेबल कंक्रीट बनाना पड़ेगा, सो दैट द कार्बन डाइऑक्साइड कैन नॉट एंटर। कार्बन डाइऑक्साइड अंदर जाना नहीं चाहिए, अंदर जाएंगे तो कैल्शियम कार्बोनेट क्रिएट करेंगे, देन अगेन द श्रिंकेज क्रैक्स विल अपीयर। एंड नॉट ओनली दैट, in the process it will start reacting with the reinforcement, and the carbon induced corrosion will create it. And what is corrosion, and what is the carbon I have made a detailed video, link is there or in the description, you will get full information. But इसको भी क्या होता है ना, अगर करोशन हुआ स्टील बार में, इसका वॉल्यूम इंक्रीज होता है, सो एंड द देयर इज क्रैक्स बॉइलिंग ऑफ द कंक्रीट इज हैपनिंग। सो कार्बन डाइऑक्साइड also can create the shrinkage crack as well as the corrosion of the steel river. So it is harmful for the concrete. So what is the things we have discovered today? What is shrinkage? What is shrinkage crack? Step by step process. how to what is the shrinkage cracks and develop in concrete, then plastic shrinkage, thermal shrinkage, chemical shrinkage, autogenous shrinkage, drying shrinkage, and carbonation shrinkage. So what is the remedy of the shrinkage? So this is the first things we need to do, that we need to monitor our curing process, because curing is the main thing, so that it will नॉट इवापोरेट द इनसाइड कंक्रीट वाटर। अगर इवापोरेशन नहीं हुआ तो हमारा सिंटेज क्रैक्स नहीं आएगा। इसीलिए आपको क्यूरिंग मॉनिटर करना ही पड़ेगा। क्यूरिंग इज वेरी 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 मच इंपॉर्टेंट। सो यू हैव टू इम्प्रूव योर क्यूरिंग क्वालिटी। एंड ऑल्सो हमने बताया कि ऑटोजेनस और केमिकल श्रिंकेज के लिए क्या होता है ना, प्रीवेटेड aggregates or the fiber we can use। and for the durability हम लोग क्या कर सकते हैं, एक लेयर पॉली वाटर प्रूफिंग का मेम्ब्रेन लगा सकते हैं, कंक्रीट को रेगुलर मेंटेनेंस कर सकते हैं, ड्यूरेबल कंक्रीट यूज कर सकते हैं। सो दीज आर द थिंग अबाउट द श्रिंकेज क्रैक्स and its remedy, and I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a video new, you will get immediate notification. And I'm waiting for your valuable comments, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.